welcome back to course Database Management System. So our today's topic of video is deadlock. So I think deadlock is a concept that you heard in case of a operating system. So in operating system you heard about deadlock. Suppose you have not heard about the deadlock in operating system, in our general life we just come to know about the deadlock situation. So first of all I will tell you what is a deadlock situation in your real life. Everyone, doesn't matter you learn a subject operating system or not, so you are aware about the concept of deadlock. So let's take a simple example. Suppose you are going by road in a particular square. Okay, in particular square obviously four routes are there, route 1, route 2, route 3 and route 4. Okay, their square is there. So in that case just imagine a situation that particular signal is out of order, that signal is not working properly. So in that case what is happening, the vehicle which is passing from route 1, route 2, route 3 and route 4 is intersecting at one place. So at that time everyone wants to pass from route 1 to route 2, route 2 to route 3 to 4, means everyone want to move from one route to another. So in that case if all the vehicles are moving at the same time, nobody is as the signal is not working properly, it is out of order, so all the vehicles are moving each other, and at intersection point all get stuck. So route 1 vehicle is waiting for route 2 to get clear the road, route 3 vehicle is getting stuck and they are waiting for route 4 to clear the vehicle. Similarly 3 is waiting for 4, 1 is waiting for 2, so all get stuck in a one position. So that position is called as a deadlock. Okay, so same thing is going also happen in case of a database. In case of a database what we have, and in case of a database deadlock occur between the transactions. In case of operating system deadlock occurs between the processes. Okay, in case of real life deadlock occur between the vehicles. So the situation is different, means the entity is going to be changed. In case of real life deadlock is between vehicles, in case of operating system deadlock occurs between the process, and in case of a database deadlock occurs between the transaction. Now let's try to understand how deadlock occur in a database between the transaction. So first of all we just define in a technical way what is deadlock. Deadlock is a situation when two or more transactions are waiting for each other to release the lock and none of them can continue as each transaction in a set is waiting queue. Simply you can take that. Suppose in this diagram there are two transactions are there, one is a transaction A and transaction B. So in order to complete the execution by transaction A it required two resources, one is a data item X and data item Y. Similarly for transaction B, in order to complete its execution it requires two data item, one is X and second one is Y. So transaction A is holding data item X and transaction B is holding data item Y. So transaction B is waiting for A to release the resource X and transaction A is waiting for B to release the resource Y. So in this way transaction A and B both are waiting for each other to release the resources and execute their task. So we can say that this situation is a deadlock where one transaction is waiting for another to release the resource and another transaction is also waiting for first to release the resource. So in that case no one can able to perform its execution, either one or two. So that situation is called as a deadlock situation. Again I will give simple example in real life. Suppose two students are there and they want to study a particular subject. Let's take an example of DBMS. Suppose one copy is available, one DBMS copy is available. See for DBMS for example two author are there, one is a Sudarshan book is there, for example another book is of Navate. So student in order to complete the assignment, student 1 want both the books, Sudarshan Koth book as well as Navate book, and both the student required both the book. So in that case what is the situation, student 1 is holding Sudarshan Koth book and student 2 is holding Navate book. So student 1 is waiting for student 2 to release the Navate book, and student is also waiting for student 1 to release the Sudarshan course book. So in that case, no student can able to complete its assignment because both are holding one and waiting for each other to release, and no one is going to release the any book. So that situation is called as a deadlock. So in that case, deadlock occurs between the student. That's why the situation is same, only entity is going to be changed from real life to operating system and from operating system to database. So I hope you understand what is deadlock in a database. So deadlock occurs between the transactions in the database. Now how to detect whether deadlock occur in the system between the transaction or not. So for that purpose you need to just construct the wait for graph. Okay, so this wait for graph consists of two things. One is a vertices and second one is edges. So this T1, T2, T3, T4, they are considered as a vertices, whereas these are called as the edges. Okay, so in this case, in this particular is there any cycle? No. In this case there is no cycle. Cycle means what? Starting point and end point is same, then we can say that it is a cycle. So in this particular graph there is no cycle, so there is no deadlock. But in this case there is a deadlock occur. So you can see here T1 to T2, T2 to T3, T3 to T4. You see here, yeah, T2 to T3, T3 to T4, and from T4 to T2. So here cycle occurs, so we can say that there is a deadlock. But there are certain situations where there exists cycle but still there is no deadlock. So that in that situation, how it is happening? Because in that case there are more than one resource, means more than one copy of the resource is available. Okay, in this case what is happening? T2 is waiting for T3, T3 is waiting for T4, and T4 is also waiting for T2 to release the resource, and no one is releasing the resource. So all these three transaction 2, 3, 4 enters into a state called as a deadlock. But in this case, just imagine a situation, there are two resources available for particular means there are two copies of particular resources available, then that problem can be solved. That's why I'm telling you, sometimes it is question will be asked to you. Means generally we are saying that when there is a cycle in the graph, then we can say that there is a deadlock. But suppose still there is a situation that there is a cycle and still there is no deadlock, so this is also be there. But generally we are using this particular wait for graph to detect whether there is a deadlock in the system or not, just by checking the cycle. If cycle is formed, that means there is a possibility of a deadlock. Okay, so this is what a deadlock detection. Now next we talk about deadlock prevention. So we talk about deadlock prevention. What is a deadlock prevention mechanism? Just we have seen how to detect a deadlock and what is deadlock. Now we'll see how to prevent the deadlock. So very first way of avoiding preventing a deadlock is no cyclic wait. So in no cyclic wait, two sub techniques are there. First, lock all data item initially. So whether it avoids a deadlock, whether it prevents a deadlock, yes, lock all data item initially. That means suppose transaction T1 required 4 resources to complete its execution. So in that case, what transaction 1 will do, it will acquire all the resources first and then start its execution. So this is one of the way to avoid the deadlock, that lock all the data item initially. Then the second way, you can put order on data item, just like in your library. Generally in case of library, number of copies is less and number of students are more. So in that case, how they are doing this, how that book can be given to all the students? So in that case they will put a rotation, that after 1 week you have to return your book and you have to take another book. Okay, so you need to put ordering on data item, just like a round robin fashion. Okay, so in this way means you just decide the order, just like your schedule, just like a timetable. Means suppose 5 subjects are there, in that case you will decide that this subject will schedule at this time, this subject is scheduled at this time. That means you will put order. Okay, so by using this also you can just prevent the deadlock. So this is a part of no cyclic wait. Lock all data item initially, and second way is put the ordering on data item. Then the second technique for deadlock prevention is use of preemption and rollback. So what do you mean by preemption? Preempt means what? just interrupt the service. Okay, I will give simple example. Suppose you are passing from the road and suddenly announcement is there on the road that VIP vehicle is coming. So in that case, what is happening? You have been prevented, you have been stopped there, and all traffic gets stuck, and that VIP vehicle is allowed to pass from there. That means you have been preempted from your journey. You have been stopped for some time, and that VIP vehicle is given the precedence to move forward. So this is called use of preemption. And what is a rollback? Rollback means what? In order to represent the rollback, I will give a simple example. Just like that, I have just given an example of that signal. That suppose the signal is not working properly, that vehicle is coming from all the side and signal is not working. So in that case, to remove that deadlock situation, what you need to do, that policeman will ask one side vehicle to roll back, means to move in the reverse direction, so that other vehicle get passed from that particular road. So this is called as a rollback. So in this case, we ask particular transaction to cancel its execution, so that the resources held by that transaction gets free and it is being given to other transaction, that the transaction can complete its execution, and then this deadlock situation can be solved. So this is how deadlock can be preempted by make use of preemption and rollback strategy. Then the third strategy is using the timestamp. Timestamp, just we have discussed in concurrency control mechanism. Timestamp is nothing but a unique ID. Okay, a unique ID that is assigned to transaction. So it involves two technique that is based on timestamp: wait die scheme, that is non-preemptive, and wound wait scheme, which is a preemptive in nature. So to explain the wait die scheme, we'll take a simple example. Suppose there are three transactions are there, T1, T2 and T3, and their timestamp is also given. For T1 timestamp is 5, for T2 10, and for T3 is 15. If T1 is requesting a data item which is held by T2, then T1 has to wait, as its name suggests, wait. That means one transaction making a request to other, that transaction has to wait. So T1 will wait. If T3 is requesting a data item held by T2, then T3 will be rollback. So that is a die, means for first transaction it is wait, and for third transaction it is what? Rollback. Then T3 will be rollback. So this is what a wait die scheme. It is non-preemptive in nature. That means T1 is requesting T2, but T1 has to wait unless and until T2 completes its execution. But suppose T3 is making request to T2, in that case T3 is not going to wait, but T3 gets rollback. So this is what a wait die scheme, which is non-preemptive in nature. Then the second scheme based on timestamp is wound wait scheme, where you can find that again the same example, transaction T1 and T2 3 with the timestamp 5, 10 and 15. So in that case scenario is different. It is preemptive in nature. If T1 is requesting a data item held by T2, then data item will be preempted from T2, that is wound. That means this is called as a wound, that T1 is making a request to T2, then T2 will be preempted, and data item from the T2 will be preempted, and T2 will be rolled back, and that resource will be assigned to T1. This is called as a wound. And suppose T3 is making a request to T2, then T3 has to wait for T2 to complete its execution. So that's why this is called as a wound wait scheme. So in this way you need to remember this, otherwise it will be difficult for you. Means you just simply remember this example, T1, T2 and T3. First scheme is wait die scheme. So in that case T1 has to wait, and T3 has to roll back. That is the simple wait die scheme. In case of wound wait, T1 is requesting T2, so in that case T2 has to be rolled back, because T1 is making attack on T2. Okay, it is requesting, so T2 gets rolled back. Okay, that's why it is wound. And suppose T3 is making request to T2, so in that case T3 has to wait. So in this way you need to remember this wait die scheme as a wound wait scheme. Okay, wait die scheme is non-preemptive nature, where wound wait scheme is a preemptive nature. So this is what a deadlock prevention. So there are three major strategies are there. One is a no cyclic wait, second use of preemption and rollback, and third one is using timestamp. Now the next topic is recovery from the deadlock. Okay, how to recover from the deadlock. So again we have been provided with some mechanism to get recover from the deadlock. So very first thing is selection of a victim. Okay, suppose deadlock is occur between 4 transactions T1, T2, T3 and T4. So in that case you need to select one transaction for rollback. So either T1, T2, T3, T4. So in that case you always have confusion that which transaction to get rollback. So in that case you should have some criteria. You have to decide this selection of a victim. So many factors may determine. So in that case there are various factors that you need to consider over here. Many factors may determine the cost of rollback, including how long transaction has completed and how much longer transaction will compute before it completes its task. That is again important thing. Means suppose one transaction is waiting from very long. Okay, how long the transaction has completed and how much longer transaction will compute before it does. Just imagine a situation, transaction 1 is already executed for 1 hour. Now to complete it required only 2 minutes, and another transaction is there which is executed only for 10 seconds. So obviously in that case you will select as a victim for transaction T2 because it has not executed that much. It can easily be rolled back. But suppose we are rolling transaction T1 back, so in that case there is a loss because it has already executed for 1 hour. So in this way first factor is there. Second, how many data item is used by transaction. For example, there are 2 choices available. Transaction T1 is holding 5 resources and still it is waiting for another, and transaction T2 is holding only 1 resource and it is waiting for other resources to get. So obviously which transaction you will roll back? Obviously T1, because it has hold 5 resources already. Suppose I am going to roll back the T1, so that 5 resource will get free and it will be allocated to different transactions. So maybe the case that their work can be executed and deadlock situation can be solved. Then the third is how many more data item transaction needs to complete. Okay, how many data item transaction need. Again the same example, transaction T1 requires 3 data items and transaction T2 requires only 1 data item. So in that case which you will roll back? Of course transaction T1, because it requires 3 data item and transaction T2 requires only 1 data item. So in that case I will select the transaction T1 because it requires more number of data item to be acquired. And fourth criteria is how many transaction will be involved in the rollback. So these are the various criteria that you can use while selecting a victim for rollback. And the second technique is of rollback. I just explained this, what is a rollback. Yeah, after selecting a victim you just roll back that particular transaction. And in that case third one is starvation. So what do you mean by starvation? When starvation occurs in the deadlock, so suppose you consider that only one transaction is selected again and again for rollback, then that situation is called as a starvation. Why it is called as a starvation? Because same transaction is again and again selected for rollback, so that transaction is not able to complete its execution. So we can say that that condition is called as a starvation. So transaction can be picked as a victim for finite number of times. So this is what recovery from the deadlock. How can you recover from the deadlock? So I hope you understand what is a deadlock, how to detect the deadlock, how to prevent the deadlock, and how to get recover from the deadlock. So we have seen this deadlock diagram, then we understand deadlock detection, then we talk about how to prevent the deadlock, and finally we discuss about how to get recover from the deadlock. Thank you.